Hello everyone. So in the last lecture we have seen the material aspect of sensors. What are the different materials that one can consider for fabrication of a sensor? We have seen that the materials can be selected based on the substrate that we use, the active materials that we use, and in the active materials also you need to check the electrical properties, then mechanical properties, then chemical properties, so on and so forth. So based on all these properties we can select the active material. Then again there are some other considerations, for example electrodes. For electrodes also we need material, for insulation we need material, for packaging also we need material. So these are the different material aspect related to sensors which we have to some extent covered in our previous lecture. Now today we will discuss the multidisciplinary aspect of sensors. Why one should learn or why one should have ideas about different disciplines while working with sensors. So before we go to that discussion, we will again see the classification slide. I mean, how many different ways we can classify sensors. So one way to classify sensor is to based on physics. So as I have listed over here, that a sensor can be classified in terms of physics. So it can be a mechanical sensor, it can be an electrochemical, it can be inductive, capacitive, optical, thermal, magnetic, microfluidic, piezoelectric, and so on and so forth. Now if you look at all these aspects closely, you'll understand these aspects belong to different disciplines. For example, the mechanical aspect belongs to, say, mostly in physics, mechanical engineering. The capacitive, inductive, these aspects belongs to, say, electrical engineering. The optical aspect belongs to, say, electrical engineering, physics, then say optics. The microfluidic aspect is something which is related to, say, chemical engineering and mechanical engineering, because fluid mechanics is involved in that. So while designing a sensor, one has to have some knowledge, domain knowledge of these fields. Otherwise it's very difficult to make a sensor for certain application. Okay. Apart from that, you'll find that sensors are also classified in terms of devices. So there are different devices also involved. This can be FET, MOSFET, MEMS and NEMS. In MEMS and NEMS again you need some information, you need some knowledge about solid mechanics. So one is to know the solid mechanics to some extent while designing a MEMS or NEMS sensor. Then this can be based on different application. For example, if you are making a sensor for bio application, for example if you are making a biosensor, you should know the bioreactions. So chemistry is also important. In fact, when you fabricate a sensor, you need to synthesize different active material, you need to deposit different active materials, you need to deposit electrodes. There also chemistry is involved. In bioreactions also chemistry and biology both are involved. If it's a biomedical sensor, for example, say the sensor is to detect the lung condition of a person. So one has to know a little bit about your lung consideration, that is the anatomy associated with your lung, how lung functions, what are the normal parameters associated with lung. So these aspects again come from, say, some medical background. So biomedical aspect, if you are making a biomedical sensor, you need some medical knowledge as well. Usually when you work with a sensor, especially when it is biomedical, you collaborate with a domain expert. For example, you collaborate with a doctor. But if you yourself have to make some sort of biomedical sensor, you should know the biology, the physiology, the anatomy of the organ that you are targeting. Then for environmental sensor, again you may need some environment expert. Again for chemical sensor, I already said that these are based on chemical reactions, so you need a person who knows chemistry very well. Then this can be based on flexible substrate, this can be classified based on substrate. So this can be flexible sensor, this can be wearable sensors. So if it's a flexible sensor, you again need to know about the bending considerations, which again is a kind of solid mechanics. Okay, so these informations or knowledge are required. Now, what is the best way to go ahead with a sensor fabrication? And over the top, because all these sensors mostly are electronic sensors, you need to know electronics for sure. So this is kind of the platform where one should stand while developing different sensors. In most of the cases, if you are developing electronic sensors, you will definitely need the electronic consideration, electronic knowledge regarding electronics or electrical engineering in order to complete the entire sensor fabrication, so that ultimately your target is the sensor should work, and if it is an electronic sensor, it should give you some certain sort of electronic output. Okay, so the best way to start fabricating a sensor is to slowly study different fields and try to understand the basic physics, basic chemistry associated with that particular sensing application. Okay, and then you can slowly start your sensor fabrication part or simulation part for that matter. Okay, then we can also classify based on dimensions. So one has to know different synthesis and fabrication techniques that can lead to a micro sensor or nano sensor. Then there are materials associated with that, so one has to also know a bit about materials. So material engineering is again to some extent needed. And then if it is based on liquid state device, if it is based on say a microfluidic channel, if it is based on a micro droplet, then you also may need to know the fluid mechanics. And probably we already have discussed the temperature sensor to some extent, where we have said that the temperature sensor response depends on the kind of interaction the active material is having with the object. If not, we haven't discussed this in a greater details, which we will do in the coming lecture, but just to put it into the perspective, I am saying that if that interaction is needed, then somebody also has to know how this heat transfer works, especially as far as the packaging is concerned. So one has to know how this heat transfer from the environment to the active material is taking place. Then only you will be able to design a temperature sensor of desired specification. So this particular slide almost provides the details about the multidisciplinary aspect of a sensor. So what I thought is like to take say 2-3 different examples of different sensors to explain how the multidisciplinary aspect associated with sensor works. I will not go deep into the details of the sensor or sensing mechanism or the circuit consideration. What I'll do is I'll quickly browse through different aspects associated with say 2-3 different sensors that I have developed in past, to give you an idea that different part of that sensor is actually associated with different disciplines. And that is why you may need to start studying a different discipline while developing the sensor, which is very usual. This is I'm not making this statement to scare you, but what I want to tell you is it's doable. Okay, so let us take our first example, where this particular paper you can find in the given reference. So this sensor is a micro droplet based disposable sensor patch for detection of alpha-amylase in human blood serum. So the idea in this sensor is to detect concentration of alpha-amylase, which is an enzyme, in human blood serum. Now, from the title itself, you can understand that there is some reaction which is required, because we are planning to detect alpha-amylase, which is an enzyme, in human blood serum. Okay, so human blood has multiple different components. Human blood has RBCs, WBCs, different other proteins, different other enzymes, but we need to detect alpha-amylase in that group of different materials, and for that purpose we need a specific reaction which will only occur with alpha-amylase present in the blood. So for that purpose, what we did is we took help of starch amylase reaction. Amylase reacts with starch very specifically, and that specific reaction we may consider in order to detect the alpha-amylase. Now the sensor that is developed is based on a micro droplet. So it's a liquid state sensor. So there is a micro droplet on top of a polyimide substrate, and there are two electrodes. These electrodes are made of, say, any metal can be used in this case, which is not reactive to the materials present. So you can consider this can be gold electrodes. Now once you have two electrodes, and when you put a droplet on top of it, if this droplet is conductive, then it will show certain sort of conductance across the droplet, right? And then in this droplet we added starch. Now this droplet has certain sort of ions. In order to make it conductive, we added some salt solution, and then we also we added starch in that droplet. Now once this starch comes in contact with the alpha-amylase present in the blood serum, they react, they create more, they break down the starch in smaller particles, and then we see a change in conductance across this droplet that we detect. Okay, so you can see in this case one has to understand the reaction happening between starch and alpha-amylase, which is a standard reaction, but you need to have that knowledge. So that is a chemistry aspect associated with it. Then we figured out, if the droplet is sitting on top of the electrode, and if we change the concentration of different concentration of amylase in here, we don't get a trend. We should, but we don't, because the reaction that is happening inside the droplet is not homogeneous. So what has been done is, like, we put heat in the substrate, and that heat created some circulation inside the droplet because of thermal Marangoni effect, which is again a fluid mechanic consideration. I am not going in details of that fluid mechanics at the moment. To keep it simple, just remember that when there is a temperature gradient, for example, if you take this entire room as a droplet, and if the bottom surface, that is the floor of this room, is heated, and the top or the roof of this room is colder compared to the floor, then there is a temperature gradient. This temperature gradient will create recirculation inside the droplet. There are two reasons behind it. One is natural convection, that you may have seen while you boil water, you find some recirculation, that is natural convection. And then there is thermal Marangoni effect as well. Okay, that creates that recirculation. Now the thermal merangony actually creates more ordered recirculation inside the droplet, but the natural convection is bit random. So we are taking advantage of the ordered recirculation so that we can make this reaction homogeneous inside the droplet, and then we can get a trend in the response with the concentration of amylase. That is, when you increase the amylase, the response is changing, either increasing or decreasing, right? So here one has to also understand the fluid mechanics in order to design that sensor. And at the end, we also have designed a system associated with it, where we have used different operational amplifiers, then voltage inverters, then sensor connectors in order to make the entire system, so that we can take this response in a mobile phone or in a laptop. So one has to have knowledge about the electronics as well. So this particular work requires microfluidics, requires carrier transport, requires chemistry, and then requires electronics. So just to develop a sensor which can detect alpha amylase in a human blood serum, you should know different you should actually have knowledge from different disciplines. That's why sensor development is a bit multidisciplinary. One should know knowledge, or one should have some certain sort of knowledge from different disciplines. One other example in this case can be the smart bandage. That is also this particular work can be found in this reference that I have given. So the smart bandage is having a wireless strain and a temperature sensor. So it's like a multi-sensory system, and then it also has a NFC tag that transmits the data from the bandage to a mobile application. So this particular sensor, or not single sensor, I would say this particular sensor system has a transparent adhesive surgical tape, it has a temperature sensor, it has a strain sensor, it has a NFC tag, then the entire thing has been encapsulated with an PDMS, then it has a wound dressing as well. This is again a kind of biomedical application. So to make this sensing system, one should know how to make a temperature sensor, then one should know how to make a strain sensor. Because strain is a mechanical parameter, one should also understand a little bit about solid mechanics, the mechanics, right? Then only you can correlate your electrical response with the applied strain. Then one should also understand chemistry, because when you are developing this temperature sensor, the active material needs to be synthesized or needs to be fabricated so that you get a temperature sensor out of it. Then definitely there is an electronics consideration in this particular application, because you are developing NFC tags, it has an entire system associated with this NFC tag. Then you have to connect the sensors with that system so that you can transmit the data to a mobile application. So one should know a bit about wireless transmission as well. So the knowledge regarding that discipline is also needed. Then it's of course biomedical. So while you are developing this sensor or this system, you should also consider the biomedical aspect of that particular work. So again, in this example, what we have seen is just to make a system, sensor system, one should have knowledge from different disciplines. Now, one way to go about this is to do a collaboration where you take help of a domain expert, or you use self-study and learn that particular aspect of that particular discipline so that you can make the sensor and can make it work. Then we have another example where again it's a multi-sensory system where it's a piezo-resistive pressure and temperature sensor module for continuous monitoring of cardiac health. Again, this works can be seen in the reference given. So in this particular work, we used a kind of pressure sensor, and one of the pressure sensors, the schematic of the pressure sensor is given over here, where you can see that P.PSS layer is used as an active material, and there are different microstructures that one has fabricated. So one should know how to do that microfabrication. So microfabrication is again needed. Then there is a temperature sensor also in this. Now in this work, what we have done is this: we have connected these two different sensors in order to accomplish a biomedical application. The application is to monitor the cardiac health. So when you do this type of work, you should know again knowledge regarding temperature sensing. Then because it's a pressure sensor, you should know a bit about mechanics again. Then electronics is anyways needed, because you are again transferring the data to one mobile application, so one has to know the electronics a bit, and then the biomedical aspect associated with the same. So in this work also, different multidisciplinary concepts are used in order to accomplish the work, that is development of a sensor module. So we already have seen different multidisciplinary aspect associated with sensor technologies, and we have seen that different disciplines or knowledge from different discipline is needed. For example, to make or fabricate something, you need some knowledge from chemistry, because you may need to synthesize different materials in order to make an active material useful for certain sensing. Then say if you are planning to develop a biosensor, you may need some details related to biology or say biochemistry. So the idea is, if you want to detect some biosample or say some biology related uh, pathogen, or some pathogen for that matter, in that case the knowledge regarding biology is needed, and biochemistry is also needed if you are detecting a biomarker from certain biosample. In fact, in case of biosensor, you may need also some knowledge in the medical domain, that is related to human health. What concentration is healthy for a human being, what concentration is alarming for a human being for a certain biomarker. I am saying, for example, you can take glucose in this case. uh, blood glucose is a kind of uh, biomarker, or is a kind of uh, constituent of the blood that actually has a lot of health implication. If the blood glucose level is too high, then a person is a diabetic, I mean in general speaking. Then it's very important that you decide, or you actually measure the blood glucose level of a certain patient at um, different period of time, or at a regular interval, to just make sure that the person is healthy, or it's the health is deteriorating. If it's if it's degrading with time, or health is degrading with time, or it's improving with time. For that matter, you need uh, a sensor that can monitor the same thing. So that's why it's important you know what should be the range at which you should use your sensor, because uh, there will be a range which is healthy, and then beyond that range it's not healthy, say unhealthy. So you need to figure out where your sensor should operate. It can operate in the healthy range. If it's all inside the healthy range, then your sensor is probably not suitable enough for this type of application. The sensor also should detect some unhealthy concentration, so that you can at least get an idea that whether the concentration of that biomarker in the blood serum is beyond that range or not. Because if it is within that range, and if you are measuring everything within that range, then you can only get data from healthy patients. If there is an unhealthy patient, you also have to check whether it is crossing that limit or not. That's why knowledge regarding human health, human physiology, human system is also needed, and that information you may get from medical practitioners, doctors, those who actually have that kind of knowledge and work with that and have that expertise. That's why multidisciplinary aspect is associated with different sensor technologies. Apart from that, what I would like to mention is, it is not mandatory that you have to have a multidisciplinary aspect. Sometimes only if you have a certain knowledge about a certain field, that should be sufficient to develop a sensor. For example, say if you want to develop a MEMS based device, if you know only the fabrication or the electrical characterization associated with it, now one may argue that again these are two different disciplines. So what I mean to say is, it need not to be highly multidisciplinary or highly interdisciplinary. With one or two disciplines also you can develop certain sort of sensor, but it depends on what application you are targeting. Usually you'll find that knowledge from different disciplines are important, and that's why many a cases you'll find that collaboration is needed. Maybe a sensor engineer is collaborating with a doctor, a biologist, a chemist, a biochemist, just to get their expertise and make a system which is suitable for that application. So multidisciplinary aspect is something that one person should understand and should realize that it's very important as a part of their research or as a part of their uh, work. There are three take home messages in this. The first one is sensor field is multidisciplinary. So just taking three different examples, what I have tried is to give you an understanding that multidisciplinary knowledge is needed while you are working with different sensors. Then in general, sensor needs an electronic system for its operation. So in most of these applications, you have seen that there is an electronic system associated with it, because you need to drive the sensor. So one can also develop a novel sensor itself. So it's not mandatory that you always need an electronic system. While you are doing the research, it's not mandatory that you also show an electronic system associated with it. But as far as the practical application is concerned, anyways you need a system. So the person who is working with the sensor should have a good knowledge about the electronic system. Then only you can make that sensor use, right? So that is what is given over here. In general, sensor needs an electronic system for its operation, and that's why you need that domain knowledge as well. Then one sensing application may require knowledge from more than 3 disciplines. We already have seen that, with one or less than 2 discipline knowledge, one can develop a sensor. I'm not saying that just by knowing electronics you can't make any sensor. It's not something like that. What I'm saying is, you may find that there are sensors, or you want to make a sensor which require knowledge from more than 3 different disciplines. So you should be open for that. So one may need knowledge from various fields, various disciplines in order to accomplish a sensor work. So let us think about, can a sensor work without an electronic system? Is it possible that you make a sensor and you don't need any electronic system for that sensor to work? Is it possible? Let's think. In the upcoming discussion, we will see different sensor terminologies. What are the different parameters associated with sensors? And we will also try to explain and understand those parameters and their significance. Thank you.